ce premier Meet&Share de l'année. Donc, il y aura c'est aujourd'hui un Meet&Share un petit peu exceptionnel parce que c'est celui de la soutenance de thèse d'un de nos membres du réseau CANCEPT, Oliver Langselius. Et on aura du coup plusieurs des personnes de son jury de thèse qui vont présenter aujourd'hui. Et donc, je vais laisser la parole à Oliver et Isabelle pour présenter ce Meet&Share qui va être en anglais. Mais merci à tous pour votre présence et votre participation. Et je laisse à présent la parole à Oliver.
So, thank you so much, everyone. I'll start immediately now in English already. And thank you. We have actually online participants joining this time because this is part of Meet&Share from the CANCEPT network that we disseminate this seminar then around France among people who are then interested in working in cancer prevention. So then we have a lot of people online. Please do ask the questions in French if you're interested to ask the question in French later on. We're going to have two presenters today. I'm not going to introduce them. They can introduce themselves. They're famous, of course, in their field. One is Professor Meinadi from Dijon, who's then going to go for the first presentation, looking a lot into the data of cancer registries. And then after then, Gianluca, Professor Severi, who is then coming from INSEM Paris, who will be then talking much more about causes of cancer. So we'll have then about 15 minutes from each person presentation. Now with the time a little bit, actually we're still fine. And then after that, we'll go then through the questions. I'll then invite Professor Meinadi then to come and present his work.
Good morning, everybody. I am very pleased to be here and thank you for the invitation. I am Marc Ménadier. I am an hematologist and I am the director of a specialized registry in hematological malignancies in Dijon. It was the oldest specialized registry in this sort of disease in the world, and we have already 42 years of registrations. So it gives us great opportunities to produce data on this disease. I am pleased to be there, and as Isabelle asked me, I will give you some examples of the role of cancer registries in demonstrated socio-demographic inequities. No. 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 Do you have something to move on? You changed something?
Yeah.
Okay. Thank you. Thank you. Yes, we are going to talk about socio-demographic inequities, and I am sure that Oliver Langselius' demonstration will be highly interesting this afternoon because he will show us that at the macro scale, it's very important to use data from cancer registries to emphasize these discrepancies. For my part, I will talk about more precise data coming from population-based cancer registries, more frequently specialized registries, or when cancer registries are involved in high-resolution studies. And I will talk about some discrepancies linked to age, sex, education, income, or political environment, and something like that. Everything that can influence the health status of the patients. And if you look at the literature, you will see that many studies have been already published talking about social inequalities or inequalities factors or things like this field. And this is true for cancer screening, which is the first part of the taking in charge of the cancer. It's also important for entering early phase clinical trials, which is very great because when you cannot access this sort of treatment, you lose your in survival. So it's a pity that people are not able to reach this to enter this sort of early phase clinical trials. And also inequities are of course the consequence of these inequities are differences in overall survival. So I will show you 4 examples in hematological malignancies to illustrate this. The first one is in diffuse large B-cell lymphoma, where we have studied the socioeconomic status and the role of this status on the survival. And the second one will talk about mantle cell lymphoma, which is a rare lymphoma, but we have combined data from cancer registry and from the LISA group, which is a big French clinical trial group, and we compare it in this disease. We compare survival in relation to the access to the clinical trial. And the third one will be data on acute myeloid leukemia, and it's a population-based study, and we look for the influence of some factors on the pathway of this disease. And the fourth example will be the quality of life, the effect of discrepancies on quality of life of patients when they are survivors. In the first study, it was a study where we included more than 1,000 cases diagnosed between 2002 and 2008 in 3 French hematological registries. We have 3 in France, one in Dijon, of course, one in Bordeaux, and one in Caen for the Basse Normandy region. And we already work together since many years, and this gives us more power to show the things. And as you can see here, I don't know if, yes, we have analyzed the survival at 5 years according to some factors. This is the period, and you see that when the period is more close to us, the survival has increased, but not so much. When you look at the geographical origin of the patient, you see some differences in survivals. It was linked to the way that the patients are taken in charge, because we are not all using the same protocols. And here you have the difference between the marital and the single status, which show that when you are married, you have a best survival than when you are alone. And more important here is the place where the patient have been taken in charge. In the blue curve, these are patients that have not access to university hospital and hematological ward. And these patients are taken in charge in university hospital with hematological ward. And this is very clear that there's a loss of survival in this situation. And when you conduct a multivariate analysis, this is absolutely true. You see if that patient taken in charge in a university hospital with oncohematology ward had 0.24 less risk to die. This is very, very important and very statistically significant. The second example I want to give you is a mantle cell lymphoma story. We compare cases diagnosed between 2008 and 2012 in 6 French cancer registry, and we compare these patients with those included in LISA trials from the same period in the same disease. And you see that when you perform multivariate analysis, that the Ann Arbor stage, of course, is an independent factor, but also age of patients. When you are younger than 65, you have more, you have less chance to survive than patients who are younger. And you can see this on these curves when, the lower curve is patient older than 26 years old, included in cancer registry database, but not only in registries. And when here you can see that patients, younger patients included in clinical trial are in blue, dark blue. In pink, you have patients less than old patients, but included in clinical trial, and in orange, patients younger, but not included in clinical trial. And you see that the difference is very, very obvious. So we have to work on building clinical trial dedicated to older patients, because when they are included in clinical trial, you see the difference in survival 4 years after the diagnosis. And this is the third example, and it's AML patients. They were 1,000 AML diagnosed between 2012 and 2016, coming from 3 French registries. And at the top, you have patients younger than 80, and in the back downstairs, you have the patient older than 80. You see, there is no, I'm not sure that you can see the numbers, but there is no difference in the way that patients are coming to the medical system when they are ill. The percentage are the same, but the difference is obvious at when to be diagnosed properly. And you see that older people here are taken in charge in a sort of general system, but when you are younger, 50% of them are taken in charge in hematological lab. So the diagnosis is complete. There are only 25% here, if I can read properly. And is a treatment unit as well, 15%, I think, yes, 24% of patients are treated when they are older than 80, are treated in hematology. But when they are younger, they are 75% treated in hematology. And of course, access to hematology unit is very different when you are old and young, you see. And these differences, you can analyze. For example, here we have analyzed mortality rate. And in black here, you have the actual mortality rate at 1 year of AML. When patients are treated, are taken in charge in a non-university hospital or in not an hematology world, you see as the actual mortality here in red. And when some statistics work calculation, we showed that the mortality is changing when you are involved or not in the university hospital team. And this is the calculation of the avoidable death at 1 year. And you see that you can win. You can 100 cases, 100 less death at 1 year when you are treated in a hospital with university hospital. And finally, I show you the data. I'm sorry for the table is very, very small, but it's a study that we have conducted on diffuse large B-cell lymphoma and follicular lymphoma. There were 177 cases from the registry of Côte d'Or. They were diagnosed between 2010 and 2017, and we asked to survival to answer questions related to their quality of life. There are many questionnaires, and you see that here is education level, And you see that education level is influenced by, is able to influence the capacity of, limitation for emotional problem, and the time series diagnosis is important as well for the vitality. But more important here, in the back of the slide, is the role of the EPICES. EPICES is an indicator of socioeconomic status of the patient, and you see that it's important on general health, on the limitation related to emotion, and as well to physical scale component. So you see that these sort of discrepancies are even important when you are treated and survival for the disease. So I hope I have convinced you that cancer registry is important to study inequalities and to be more precise and big studies. Thank you very much.
I don't know whether we should be taking questions and then move to Gianluca, because it's easier probably while Mark is still on the stage. Pauline, what do you think?
We don't have questions yet, so I think we can pursue. And if people have questions, don't hesitate to ask in the Q&A, and then we can reply at the end.
I have already questions, but we can do that later. So maybe then I'll give then the floor to Gianluca. Now I'm thinking we're going to have the same problem of trying to find the slides and present it. And I'm looking at the person who is much better technically than myself. This is already here.
N'hésitez pas, si vous avez des questions en français, à les mettre en français dans le questions-réponses. Et puis, ça sera répondu à la fin de la présentation. Ou on les traduira. Donc, ne vous inquiétez pas, vous pouvez mettre en français. Merci à tous pour votre présence.
Because of the Mac. Yes, you're right. Thank you.
We still see the old presentation, but
See this now or not yet, Pauline?
no, not yet. We still see the old one, and it's flashing with the blue computer, but I don't see the new presentation yet.
Now?
Yeah, I can see it now. The role of exposome, and it's moving, so it's working.
Okay, good.
Perfect. Thank you very much.
Oh. Why is it doing that?
It's working from all sides, Oliver.
Yeah, now it's not showing in the room. So.
Ah.
Oliver, on the side, it was working.
That's working? Oh.
Wait 1 second. That's the strength of doing it online and in person, but it will work.
Pauline, can you see it now?
Yeah, I see the slide in
Perfect.
white. I think it's working.
Okay, good.
Perfect.
Thank you, and thanks for the invitation to present. It's the first time that I participate in a thesis jury, and I have to present, and it's a good idea. My name is Gianluca Severi, and I'm a cancer epidemiologist. I lead a team that is called Exposome and Heredity, and I'll explain why the title of the group is Exposome and Heredity. And we are based in Villejuif, it's just south of Paris, in the Center for Research on Epidemiology and Population Health, the CASP. Oops, I cannot move. No, it doesn't move. We get there.
It's working. It's working well.
Okay, good. Thanks.
Thank you.
It's working. So the reason why my team is called Exposome and Heredity is because we are interested in both dimensions. On one side, the exposome, and I'll give you a definition. Probably most of all of you know what is the exposome, but also on the side of the genetic factors per se, so the genetic susceptibility, but in particular also because we believe also the interaction between the genetic component and the exposome is particularly important. And also, I'll not have the time to mention this, but also the omic component, the omic tools are extremely important, and we work quite a lot on omic analysis that help to disentangle also the role of the exposome and the different dimensions. Okay, so, and I don't need to repeat this, but we all know that cancer is a multifactorial disease with all the different dimensions listed there. I mentioned the genetic factors. There is a strong focus of also our team, but I'll focus my presentation in particular on the environmental exposures and on the concept of exposome in broader terms. So the exposome, I don't need to mention Chris Wilde, that was director of this institution, that was the person that proposed the concept of exposome. And I wanted to highlight with this slide the complexity of the different dimensions of the exposome, including individual factors like lifestyle, the different lifestyle factors, the different exposures, environmental exposures, but also the contextual factors. And I mean in particular, for example, in this slide taken from a publication from Royal Vermeulen called these ecosystems, so the food environment, and not just the single foods. I'll talk about the foods and micronutrients, etc., but there's also the broader context, the availability of food in the neighborhood and things like that. But also socioeconomic, we have seen the importance of socioeconomic factors and socioeconomic context. The next slide is also to repeat the concept I told you before, the gene-environment interactions, genetic loads, the guns, but the environment pulls the triggers is a famous quotation from Judith Stern. And very important questions: why people with similar exposures do not all develop diseases? And I'll give a hint about that. Why some individuals are more vulnerable than others, so also the genetic makeup, but not just the genetic makeup. And why certain genes increase risk only under specific environmental conditions. Basically two different approaches to the study of the different dimensions of the exposome. What I call the bottom-up approach is basically the external exposome of an individual described and quantified and I'll show you some examples, and I'll focus mainly on this. And then the top-down approach is basically all internal exposures that are measured in an individual biological material. So taking biological samples, measuring, for example, the presence of some contaminants, and basically these two dimensions are both very important, and ideally we would really like to put these two approaches together to get the broad picture. And one thing that I wanted to highlight here in the bottom-up approach, that would be the focus of my presentation, is the fact that we have different sources of the main exposure. For example, of a single contaminant, often we have exposures that come from different sources, for example, from the diet, and I'll talk about these, from the air, from the soil, etc. Okay, so another important message is also that a single biomarker, even measured in the blood or other biological materials, could be used as a marker of exposure or a marker of effect. So we have to take this into account. I'll not have time to talk about the different omics, but I mentioned before there is a very important focus of my team. And also there are other key aspects. Of course, we are also dealing with exposures that are often strongly correlated one with the other, and I'll mention an example of these, and also we have interactions between different exposures, and I'll also show you an example of that. And here is a list of things that we will talk about just in a minute. So we have different types of exposures: chemical, physical, exposome. For example, I will not talk about physical, but we are currently doing some work on noise, exposure to noise, exposure to light, artificial light. There are fields that are particularly interested. We recently published a paper on artificial exposure to artificial light and breast cancer risk. They show interesting results of a positive association. There, of course, need to be confirmed in other studies, but at the moment there's not a lot of literature on this. But of course, there are quite interesting hypotheses behind this. What I'll focus on is, in particular, dietary exposures and contaminants through diet. If I have time, I don't know, I'll also give you some examples of work on atmospheric exposome. That is a work in collaboration and coordinated by the CLB with Beatrice Fervers, and we have done a lot of work on this, and we'll continue to work together on this topic. Okay, so I said my focus today in this brief presentation is in particular the dietary exposome. So through diet we are exposed to macronutrients, micronutrients, but of course a lot of other things: pesticides, food additives, mycotoxins, and environmental contaminants more broadly. So all this is not easy to study because, as I said before, there are strong correlations between, for example, the different foods, the contaminants, the macro and micronutrients. So I'll the main, just open a parenthesis to describe the main tool we use, the E3N generations cohort. So the E3N generations cohort is originally a cohort of women, just women, 100,000 almost, affiliated with the MGen, that is the National Education System, recruited back in 1990. and they were aged 40 to 65 at baseline in 1990. So you see here the different questionnaires, starting from Q1 is the first questionnaire at recruitment, and then you see every 2 to 3 years has been another question, and still the E3N women complete the questionnaires today. Of course, the cohort is now more limited, but there are still more than 50,000 women E3N that complete the questionnaires, and a substantial proportion of the women have died during the follow-up. That is now we are more than 35 years of follow-up. And you see here the main topics of each questionnaire. Of course, there's always a section on health, but also sections on different topics of interest. And I don't need to talk to you about EPIC, but E3N, the original cohort of 100,000 women, or actually more precisely, the 73,000 that have completed the first food frequency questionnaire are the French component of EPIC. And I will not have time to go into this, but a more recent development of the cohort is the development into familial cohort with different generations. First of all, the partners, 18,000 have been recruited already. We are recruiting currently the second generation with 21,000 currently recruited, and we'll start recruitment of the third generation probably towards the end of this year. Of course, the objective is to study more recent exposures, to study transmission of risk factors and also diseases across the different generations. There's also an important point, a large biological collection, blood samples collected in 1995, 1997, saliva sample, some tumors collected more recently, and also a study that collected Guthrie cards for a COVID-19 project. And we do quite a lot of work, as I said, on the blood samples, omic analysis, etc. But I want to especially focus, as I said, on the food frequency questionnaire. That has been repeated also more recently in 2005, but the first one, that is basically the moment when we basically were included in EPIC, is in 1993. So the idea was that you see here a section of the questionnaire that has been used for studies on micronutrients, food items, dietary patterns, etc. But more recently, thanks to the work of Francesca Mancini, a scientist in my group, crossing the data on the food frequency questionnaire and the data from ANSES, that basically did a survey for a long list of foods. They measured a long list of contaminants, more than 400 different contaminants. So crossing these two information, we got the individual exposure to these 400 and something contaminants. A lot of work has been done, and I'll give you an example. But just before doing that, I just mentioned the fact that also we have geocoded the place of residence at recruitment, but also for the follow-up questionnaires. And this work is the basis also for example, the work in collaboration with Beatrice Ververs on air pollution, for example, on noise, as I said before, artificial light, etc. But and this highlights this collaboration with Beatrice Ververs on different pollutants, atmospheric pollutants. But let's go back to the food contaminants, and I'll give you just an example of PBDE, the polybrominated diphenyl ethers, that are kind of flame retardants. That have been used commonly and accumulate in the environment. And the problem with these contaminants is that they are suspected of acting as endocrine disruptors. And then the hypothesis that these would be associated with breast cancer. So the PBDEs are also lipophilic, and diet is a main source. So, for example, fatty food or fat in food in general. And also there are some interesting in vitro studies that have shown that vegetable oil increase the bioavailability of the PBDEs in the body. So we had basically two hypotheses. The first one was to evaluate the association between dietary exposure to PBDEs and the risk of breast cancer, and in particular ER-positive breast cancer. And the second objective was to try to investigate the potential modifying role of vegetable oil consumption on this association. Here you see the DAG that take into account also the different potential confounders. Here is PBD intake. So the hypothesis, the association with breast cancer, and also the role of dietary consumption on, for example, total calories taken, risk of breast cancer, etc. So overall, we did not see a clear evidence of association, potentially a very small association for high levels, the fifth quintile and the fourth quintile of PBDE exposure through diet. But when we looked at separately people that consume smaller quantities of vegetable oil and people consuming quite a lot of vegetable oil, we tested the interaction that is significant, but it's quite interesting. What we found that seemed to be consistent with what is reported in vitro studies, where due to the fact that PBDs are lipophilic and therefore high oil, vegetable oil consumption would increase the bioavailability of PBDs, and therefore you see a significantly higher risk of breast cancer. Of course, this needs to be replicated in another studies, but it's an interesting result. And it also shows the complexity of things, because we say, of course, that, for example, olive oil consumption is very good for your health, and it is, of course. But the things have become very, very complex with the presence of different contaminants. Another aspect, I don't have results directly for cancer, but we did an analysis for mortality, overall mortality, looking at, here you have clearly the example of, we have seen a specific class of contaminants. We have so many. So we have mixtures. We are exposed to mixtures of contaminants. So we have to take this into account. Here with the technique of sparse non-negative matrix factorization, we have identified with our data 6 main mixtures of contaminants. And therefore, the question is any of these mixtures associated with cancer, for example? We haven't done this yet. We have done this for mortality. And the interpretations of the results are quite difficult, because you can imagine here you have 2 mixtures, for example, associated with pesticides, but pesticides come from vegetables and fruit. They're of course associated with are good for your health and generally associated with lower levels of mortality. And the idea is to try to do this also in association with cancer. I think I don't have time to really talk about the work on air pollution, but I think what I've shown you is give you an idea of a hint of what we are doing. I think I can stop here, and of course I'll be happy to take questions if there are any.
Thank you so much for the two presenters. I don't know whether there are questions then from the room, but also then online, but I think I'll ask then the first question, being having the privilege of then chairing this meeting. So I'll have then one question for Mark and one other question for Gianluca. For Mark, I thought that was really interesting, the study that you mentioned on the contributors of different factors on survival. And then I thought some of them, the factors could, like, for example, universities, hospital or non-university hospital, age and clinical trial or involvement in clinical trial. Has this been then used in anyhow? Because for me, in France, it's a country of égalité. So then you expect that there shouldn't be differences that comes from hospitals. There shouldn't be differences that comes from things that are part of the health system. That's what you expect. How do we then in France, or what has been then the influence of this paper? Can it be taken into kind of practice, in clinical practice, to improve survival? I'll give Mark first then, and then after that I'll pose my second question.
Thank you, Isabelle. Yes, of course, France is a country of equality, but you see that it's not true. And the paper has been well received by the clinicians, but and they try to influence this, the things to get the patients involved in their hospital. It has been taken in account by people working in hematology, and hematology ward I mainly located in university hospital. So they were convinced already that it's more important to take in charge the patient. But it's something that it's difficult to change, because not all patients can be welcome in all the number of the ward available. We have to reorganize, if I could say that like that. But it will take time. Yeah. It will take time. But it's.
I think that's also the power of registries, no? Yes. That you can follow it up and see whether there's improvement over time.
Yeah, absolutely.
Yeah. Okay. And then my next question for Gianluca. I saw that you're doing now the cohort for the really youngest people. For me, EPIC and E3 has always been cancer and causes of cancer. But then with even 50,000 children, I think the chance of getting childhood cancer would be, or then you have to wait a long time until those children become adult. What is then the plan with this cohort in terms of looking into causes? Are you looking into new diseases or new exposure?
Yes, so thank you. The 50,000 is the target. So we don't know where we will get there. But, and also we are actually limiting, we have decided to limit the recruitment to older than 18. We are not recruiting minors. And also I believe that you would need a really much larger cohort to study childhood cancers because of the heterogeneity. It's so heterogeneous, so I believe, I don't know whether it will be possible to study in a cohort of people that are free of cancer, really childhood cancer. And also because and also the causes of childhood cancer, I think they are very, very different. But so our objective is really, yes, to study more recent exposures, of course, because, for example, the diet I talked about is the diet in 1993. The diet has changed a lot. And we're actually going to send a new dietary questionnaire to all the cohorts, including the second generation, in a few months. and these will capture a more current diet. We are also testing some other tools to capture diet. There are now some apps. There's definitely nothing really established yet, but I think it's worth trying to test other ways to capture diet. And of course, because I mean, there are papers on ultra-processed food, etc., which are very interesting, very important results. But again, also we need to study this type of food more in detail, and also ultra-processed food is again based on data on diets in 1993 or in the early 90s. Now it's very different.
If I think of when my children are 18, so if I think what they eat, the junk food that they eat today, I mean, and then what I ate when I was 18 around the 90s, it was really very different. Yeah, so it would be very interesting. Can I ask whether anyone in the room or there is any question then from the online participant? Any question from Mahdi? Go ahead. I will repeat the question if needed.
Hello. Great presentation. Thank you very much. Jean-Luc, I have a question on the cohort, actually, au trois. Do you have also biosamples? I know you said 25,000 at the beginning of the study in 1990s, but do you have repeated samples because, you know, you have information on, okay, no.
Unfortunately not. We would love to. We don't have a repeated blood sample. We are going to launch a biological sample collection, but limited to the second generation and the third generation. I mean, there's also the issue that now the Istrian women are quite old. Yeah. It's quite difficult to get, I think, a biological sample. Although I mean, I've talked about the project on COVID-19. So there are blood from Guthrie cards. So if you think about something that can be measured in whole blood and Guthrie cards, that can be used as a repeated sample.
Just a question also, those samples, do you have any genetic data on those or nothing has been done?
We have DNA on all the 25,000 plus the 47,000 given saliva sample. They are not the same women because the objective was to have at least 3/4 of the cohort with DNA samples. And we are doing genotyping on these thanks to a large funding on our cohort. On the cohort Constance, it is another large and more recent cohort. We are doing the genotyping on all the participants. So it will be available. Probably we'll need another 1.5 years to get the data.
Any further questions from, we have a bit of 2 minutes, so we have time for one more questions probably online. Any questions from the group here? If not, for the CANCEPT team, there's going to be, or a lot of the CANCEPT participants, there's going to be an international advisory board meeting soon. And then I think I will then close here then with the 2 minutes that we saved. And thank you so much. And I'll give then the word back to Pauline.
Thank you very much, Isabelle, for the very interesting presentation and for all the speakers. We are really grateful for this presentation on exposome and cancer inequalities. And now we are gonna go for the one participating to the ISA meeting, to the next team meeting. And for all the participants, thank you very much for your participation. And we have the next Meet&Share on first day on implementation. So it will be also really interesting with an international speaker from the USA. So I will see you on first day and have a really nice meeting also for Oliver and a good thesis presentation for Oliver. Best of luck.
Thank you, and thank you also then for those people who are in the room. For those who want to continue participating in Oliver's presentation, It will start at 3, so we will have then a half an hour break, and then we'll continue with. And thank you so much for Mark and Gianluca for a very nice presentation. Thank you all.
Wow.